Lesson 27 Synchronizing with Effects. 1. Introduction. Good morning, afternoon everyone. In this session, we are going to explore how components in a user interface framework synchronize with systems outside of their immediate control. We'll learn how this mechanism works, how it differs from regular event handling, and what you need to watch out for. The goal is to deepen our understanding of when and how to step out of the internal component logic and align with an external system, be it a network connection, a browser API, or a third-party widget. 2. What effects are and how they differ from events. Let's begin by clarifying what we mean by effects. Inside a component, there are two broad types of logic. First, the logic that describes what should appear on the screen. This is essentially a pure calculation. Given input, props and state, produce output, the UI. Second, the logic triggered by user actions, clicks, typing, navigation, which we call event handlers. Event handlers are explicitly tied to user-driven interactions. An effect, by contrast, is logic tied to rendering itself, not directly to a user click or typing event, but rather to the fact that this component has been rendered or updated. For example, when a component mounts, or when certain values change, you may want to connect to a service, register a listener, fetch data, or synchronize with a non-component resource, like a video player, DOM API, or network socket. These are side effects triggered by render outcomes, not by explicit user actions. 3. You might not need an effect. Before diving too eagerly into adding effects everywhere, pause for a moment. Remember, effects are needed when you synchronize with something external to your internal rendering logic. If all you're doing is deriving some state from other state, or adjusting internal values, you may not need an effect at all. Overusing effects can complicate your components, make behavior less predictable, and introduce subtle bugs. So always ask, is this logic about synchronizing outside of the component environment? If not, maybe we stay inside the rendering and event handler realm. 4. How to write an effect. When you do need an effect, there are 3 key steps to follow. Declare the effect. At an appropriate place in the component, you define what should happen after rendering. Specify dependencies. You indicate which data or inputs the effect depends on, so that it only reruns when those inputs change, rather than after every render. Add cleanup if needed. If your effect establishes something that must later be undone, such as a subscription, connection, timer, or DOM change, you must define how to clean up when the component is unmounted or when dependencies change. We'll unpack these steps in more depth. 5. Step 1. Declare an effect. Declaration means placing the synchronization logic in the right lifecycle phase, after the render has happened and the output is committed to the screen. Why is this important? Because you must avoid doing side effects during the pure render phase, which should remain free of mutations, DOM manipulations, state modifications. Instead, you wait until after the UI update, then perform the synchronization. For example, controlling a video playback element after the UI is present, connecting to a chat service once a component is mounted, or registering a listener on a widget only when the component appears. 6. Step 2. Specify the effect dependencies. If you leave the effect to run after every render indiscriminately, you may incur performance hits, unnecessary network traffic, or even infinite loops. Dependencies tell the system, only rerun this effect when these particular values change. If no dependencies are given, it typically means run after every render. If an empty set of dependencies is given, it usually means run only on first render, mount. If one or more values are listed, it means run when any of these values change since the last time. As you list dependencies, you also help ensure your logic only triggers when necessary. 7. Step 3. Add cleanup if needed. Many effects allocate resources, They open connections, add event listeners, start timers, or mutate things outside the component. Without cleanup, these resources may linger, causing memory leaks, duplicated behavior, or missynchronization. Cleanup means when the component is unmounted, or when dependencies change and the effect is about to rerun, you must undo or close whatever you opened. This ensures correct behavior both in normal operation and in development where special checks are done. 8. How to handle the effect firing twice in development. In many setups, the component framework may mount, unmount, or remount components in development mode in order to detect errors in effects and cleanups. As a result, you may see the effect fire more than once even if you only intended it to run once. The key is, don't try to prevent it firing twice. Instead, make sure your cleanup makes the effect safe to rerun, or safe to mount again. If you design your effect so that it behaves correctly when run followed by cleanup and run again, you are robust. In production, the effect may only run once. In development, you may see extra cycles but no visible difference for the user. 9. Additional patterns and pitfalls. There are further considerations. When you control non-native widgets, for example, a map library or modal dialog, you often need to sync your state with the external API, and sometimes cleanup is minimal or non-existent. If you subscribe to events, scroll, resize, custom events, you must unsubscribe in cleanup. If you start timers or fetch data, you must ensure you cancel or ignore the results when the component unmounts or when inputs change, to avoid stale updates. Be cautious. Some logic should not live in an effect. For example, one-time initialization of the entire application or user-driven interactions like, buy this product, are better handled outside effects, in startup code or event handlers, because effects can run more than once in development. 10. Recap. Let's summarize the key takeaways. Effects are not event handlers. They are logic tied to rendering and synchronization with external systems. Use them only when you need to step out of the component and talk to something outside React's declarative render. Declare the effect after rendering, specify appropriate dependencies so you don't run unnecessarily, and always clean up any resources you allocate. In development, you may see extra effect runs. Ensure your code handles that gracefully rather than fighting it. Always ask whether the logic is truly an effect or simply something internal. If it's internal state derivation, you might not need an effect at all. 11. Closing thoughts. Understanding effects is crucial to building reliable and efficient components, especially when your interface touches APIs, external libraries, or persistent systems. When you apply the three-step discipline, declare, depend, clean up, you make your components predictable and maintainable. And when you remain mindful of the difference between rendering logic, events, and synchronization logic, you avoid many common pitfalls. I encourage you to reflect on your components. For each piece of logic, ask, is this purely rendering? Is it triggered by a user action? Or is it synchronizing with an outside system? With that clarity, you will apply effects more thoughtfully and your codebase will benefit.